In this screencast, we discuss horizontal intercepts of quadratic functions. In the last screencast, you learned that a parabola can have two horizontal intercepts, which means the parabola looks something like this and hits the horizontal axis in two places, or a parabola can have one horizontal intercept, which basically means that the parabola's graph must look something like this and hit the horizontal axis in exactly one place. Or a parabola can have no horizontal intercepts, which basically means the parabola never intersects the horizontal axis. These are the only possibilities for a quadratic function's graph. It can either have two, one, or no horizontal intercepts. But how do we locate these horizontal intercepts if we don't have a graph to look at? How can we use our algebra skills to find horizontal intercepts? That's what we're going to focus on in this screencast. If you take higher level algebra courses, you'll see that there are multiple approaches for determining horizontal intercepts of quadratic functions. Here, we are going to discuss one approach, and it uses the following basic property of numbers. It's called the zero product property, and this is what it says. If you have two numbers, A and B, and you know that their product is 0, it follows that one of the two numbers must be 0. Either A must have been 0 or B must have been 0. We'll use the zero product property in the next example, 11.6. Factor each of the following quadratic functions and then use the zero product property to determine each function's respective horizontal intercepts. So let's look at part A. Notice that it is a quadratic function. It has the form ax squared plus bx plus c. So first of all, let's factor the equation for this function. We've done this before. This should be a review. We know that it should factor into a form like this. In order to determine the two numbers here and here, we have to find two numbers so that their product is 5 and their sum is -6. And -5 and -1 work. You can check. -5 times -1 gives a +5, and -5 plus a -1 gives the -6. Okay, so really what we've done is we've taken our function, which was written in the standard form this way, and we've expressed it as a product of two linear factors. And if you recall from our earlier screencast, a quadratic function is a function that is a product of two linear functions. Factoring will take your function and write it in that form. Okay, so our goal is to determine this function's horizontal intercepts. So remember, to find a horizontal intercept, you always set the output of a function equal to 0. So we're going to set the output y equal to 0 and find x. The x values we find, those will be the horizontal intercepts. So let's do this. If I set y to 0, I get 0 equaling x minus 5 times x minus 1. So let's look at what we have here. We have a product. This times this is equal to 0. So if we think about the zero product property, we have a product of two things equaling 0. This times this equals 0. The zero product property tells us that one of these must be 0. That's the only way the product could be 0. So we know that either x minus 5 is 0 or x minus 1 is 0. One of these must be true. So that tells us that either, if this is true, that tells us that x must have been 5, and if this was true, that tells us that x must have been 1. So we arrive at the conclusion that either x is 5 or x is 1. So in other words, when we set our output to 0, there are two values of x, 1 and 5. Both of them cause y to be 0, and we can check. If I take 5 and I substitute it back into our function, if I substitute 5 here and here, I get 5 minus 5, that's 0, times 5 minus 1, that's 4. I get 0 times 4, and that product is 0. So setting my output equal to 0 yields two values of x that would cause y to be 0. So our conclusion here is that there must be two horizontal intercepts. So there are two horizontal intercepts, and they are located at x equals 5 and x equals 1. That's where we would look for them on a graph. Let's try part B. Our function now is u at t equaling t squared plus 3t minus 4. And again, you can see that it is a quadratic function. It has the form ax squared plus bx plus c. Let's start by factoring it. Okay, when we factor this, we have to find two numbers whose product now is -4, and that sum to 3. And we find that a +4 and a -1 work. So that's the factored form. And so once again, we've written our quadratic form as a product of two linear factors. Now let's find the horizontal intercept. Again, to find a horizontal intercept, we set our output to 0. So here we set u of t, that's our output, equal to 0, and we find, in this case, what t would have to equal. When we set our output to 0, we get 0 equaling t plus 4 times t minus 1. We apply the zero product property because we have a product of two things equaling 0. That tells us that either t plus 4 must have been 0 or t minus 1 had to have been 0, which further implies that either t must have been a -4, because that's the only way t plus 4 could have been 0, or t must have been 1, because that's the only way this would have been 0. So when we set the output of this function equal to 0, we find that there are two input values. We find that there are two two input values that cause the output to be 0. That means, again, there are two horizontal intercepts of this function. Namely, t equals -4 and t equals 1. Okay, let's look at our next example here. Let's begin by factoring this function. Again, you can see that it is actually a quadratic function. So let's factor it. This time it factors as x plus 1, or y plus 1, times y plus 1, which, notice, we could write as y plus 1 squared. Now, to find the horizontal intercept, we set the output equal to 0. So here we're going to set g at y equal to 0, and our goal is to find y. When we set our output equal to 0, we arrive at 0 equaling y plus 1 squared. And now let's think to ourselves, what value must y be that would cause this to equal 0? Well, I think you would agree, probably, that y would have to be -1. This example is a little different than the previous two examples. In the previous two examples, we found that there were two input values that caused the output to be 0. But in this case, there's just one input that causes the output to be 0. That tells us that in this particular case there is only one horizontal intercept. Namely, it occurs at y equals -1. Let's look at part D. We begin by factoring this function. So, first thing we can do here is write this quadratic function in standard form. Notice there is no term that involves just x. There's a x squared term, but there's no term that involves just x, but we can always insert it. So it's really a 0 times x here, and then -9. Why would we do this? Well, when we're factoring like this, it might be helpful to have this middle term in here. We're looking for two numbers whose product is -9, and now we can see that when we add these two numbers, we have to get a sum of 0. So turns out that a +3 and a -3 accomplish that. So that is the factored form for this function. Now let's find the horizontal intercepts. We set our output equal to 0, and in this case we have to find x. So we set our output equal to 0. And we use the zero product property. We have this times this equaling 0. Therefore, one of these must be 0. So either x plus 3 is 0, or x minus 3 is 0. Consequently, either x is negative 3, that would happen if this was true, or x must equal 3. And that would be the case if this was true, because 3 minus 3 is 0. So what we've found is that when we set the output equal to 0, there are two values that x could be that would cause y to be 0. Therefore, there are two horizontal intercepts. And they occur at x equals negative 3 and x equals 3.